In this video, we will review a variety of integration techniques, starting with quotients. When you integrate a quotient, sometimes you will simply do U-substitution, whereas other times we will use these inverse trig rules. So how do you know when to do inverse trig and when to just do U-substitution? It depends on the degree of the numerator versus the degree of the denominator. If the degree of the denominator wins by 2 or more, then you will use inverse trig rules. On number 8, the degree of the denominator wins by 2, so inverse trig, I don't even have to complete the square this time. Obviously, this is a perfect match for arctangent. We already have x squared, so we don't need U substitution at all. We just need to acknowledge that a is 2, because a will be the square root of the constant. So we can actually jump right in and use the rule to integrate. So in the front we see this 1 over a. So we're going to have 1 over 2. And then arctangent. And then u over a, but we didn't do a u substitution, so that'll just be x over 2 plus c. Kabam! The degree of the denominator wins by 2, so I know this will ultimately be an inverse trig rule situation. However, the presence of this trinomial tells me that I need to complete the square first. So let's do that first. When I have a negative leading coefficient, I really want to bring that outside some parentheses. So I'm going to do that first. In fact, I think I will use a bracket because I'm going to have parentheses inside of here. So I'm bringing out the negative sign. So I have x squared minus 4x. Okay, and then plus 3, but I'm going to leave a space here. And I'll put the plus 3 like here. Okay, and I'm leaving some extra space after this for reasons. So now I am going to complete the square. I need a special number here for the third term. How do I get the special number? I use the phrase half the middle squared. So the middle is -4. Now if I take half the middle, that's -2. And then if I square it, then that's 4. So that tells me what the magical third term needs to be. So I'm going to put a plus 4 right here. So fine, I have now completed the square. But this is, I changed the value of the problem by putting a plus 4 here. So I need to put a minus 4 right here to balance that out and make it valid. All right, this way I've really added 0. Nothing has changed. Why did I do this? It's because when I put the special number here, it will create a trinomial that will factor as the same binomial twice. So this will be x minus 2 times x minus 2. You can tell the sign because of the middle sign. Meanwhile, 3 minus 4, that's -1. So I have this. Let's not leave x minus 2 times x minus 2. Let us instead write x minus 2 squared. So I have x minus 2 squared. So remember, I have this negative sign outside of the bracket. That doesn't show up in any rule. So I need to deal with that. So remember, if I have negative, let's say a minus b, this is the same as positive this is the same as b minus a without the negative sign in front. Okay, so that's what I'm going to do. So if I reverse these, the negative sign will go away. And that's really just a shortcut, but it works. So I'm going to put 1 minus x minus 2 squared, now without the negative sign. So this is the same value as this trinomial. These are equivalent. Hey, if you're uncomfortable with the little shortcut I was doing over here, you could show this one extra step. And you could distribute the negative sign like this, and then you can see that I can just rearrange the order of these terms. I could put my positive 1 in the front and my minus the quantity x minus 2 squared last. Anyway, replacing the trinomial with the new version, we have this. Which inverse trig rule are we going to use? Well, it's not going to be arctangent because we see a negative sign and we see the square root. I see a constant minus the variable. So constant minus the variable, that's arcsine. Comparing with the inverse trig rule, we can see that u must be x minus 2. So u equals x minus 2, which means that u prime is equal to 1. And also we know that the a value is equal to 1 because that's the square root of the constant. If we go ahead and make this substitution, we have the integral of 1 over the square root of 1 minus u squared. Instead of dx, we will write du over u prime, but u prime is just 1, so that's it. This is now a perfect match with the rule, so we can go ahead and use the rule to integrate. So we have arcsine, all right, we have arcsine u over a, but a is 1, so it's really just going to be u plus c. Putting x minus 2 back in for u gives us the final answer. This will not be an inverse trig rule because the degree of the denominator only wins by 1. So let's go straight to the U-substitution, which in this case is so simple, most of you could probably do this in your head. I'm going to show it for instructional purposes. U will be the x plus 3, which means that u prime will equal 1. So that would give us the integral of 5 over u. Instead of dx, we will write du over u prime, but u prime is 1, so it's really just du. Let's put the 5 out in the front of the integral. So I have 5 times the integral of 1 over u du. Here is a rule that we have memorized. The integral of 1 over u du is equal to the natural log of the absolute value of u plus c. So that's what's happening here. So we will have the 5, we're bringing down the 5, but then natural log of the absolute value of u plus c. Putting x plus 3 back in for u, we have the final answer. In number 11, the degree of the denominator wins by 1. So let's just do U-substitution. We will let u equal the entire denominator. So u will equal x squared plus 1. That means u prime will equal 2x. Let's do the substitution and see what happens. So we have the integral of 2x over u. Instead of dx, we will write du over u prime, which is 2x. We notice that we have a 2x in the numerator and the denominator, so these cancel each other out. And that leaves us with the integral of 1 over u du. So here comes the memorized rule. The integral of 1 over u du is the natural log of the absolute value of u plus c. Putting x squared plus 1 back in for u gives us the final answer. You might notice that I switched over to regular parentheses instead of the absolute value. We don't need the absolute value because x squared is always positive, and then adding 1, you still have a positive number. It's okay if you put the absolute value, but it's not needed in this case. Taking a break from the quotients for a minute, let's do some u substitution. So u will equal the exponent of 7x, which means that u prime will equal 7. So if we do that substitution, we get the integral of e to the u. Instead of dx, we write du over u prime, which is 7. The 7 in the denominator can be put in the front of the radical as 1/7. So we have 1/7 the integral of e to the u du. This is a memorized rule. The integral of e to the u is e to the u plus c. So just don't forget the 1/7 that's in the front. Putting 7x back in for u, we have 1 over 7 e to the 7x plus c. And this is the final answer. All right, more u substitution. Let's let u equal the entire exponent. So u will equal 3x squared plus 1. That means that u prime will equal 6x. Let's do the substitution. So we have the integral of x e to the u. Instead of dx, we will write du over u prime, which is 6x. We notice that we have x in the numerator and x in the denominator. Those will cancel each other out. The 6 in the denominator can be brought out front as a 1/6. So we have 1/6 the integral of e to the u du. So, memorized rule time. The integral of e to the u du is e to the u plus c. Just don't forget your 1/6. Putting 3x squared plus 1 back in for u, we have the final answer. Very interesting. Looks like more u substitution. Again, let's let u equal the entire exponent. So u will equal sine x, which means that u prime will equal cosine x. Let's do the substitution. So we have the integral of e to the u cosine x. Instead of dx, we write du over u prime, which is cosine x. Right away, we notice that we have cosine x in the numerator and the denominator. These cancel each other out. That leaves us with the integral of e to the u du. The memorized rule is this integral is e to the u plus c. Putting sine x back in for u gives us the final answer. Number 15 will just be the application of a memorized rule. The integral of a to the u du equals a to the u over natural log a. So we can apply this rule here, where a is 5. So we get a to the u, so that's just going to be 5 to the x, divided by the natural log of a, so the natural log of 5. I forgot the plus c. So of course this rule includes the constant of integration. So that's all there is to number 15. Looking at number 16, you can easily see that 1 over 3x is the same thing as 1/3 times 1 over x. I normally wouldn't even show this step, but I want to make it clear that I can take the 1/3 and put it out in the front of the integral, and that will leave 1/3 integral of 1 over x dx. And here comes the memorized rule. The integral of 1 over x dx is the natural log of the absolute value of x plus c. And then we still have the 1/3 in the front. And there's your final answer. Number 17, the degree of the denominator wins by 1. So let's go straight into u substitution. Let's let the entire denominator equal u. So u will equal x to the 3rd power minus 1, which means that u prime will equal 3x squared. Let's do that substitution. So we get 3x squared over u. And instead of dx, we write du over u prime, which is 3x squared. And right away we see that we have 3x squared in the numerator and the denominator. So these just cancel each other out. And we are left with the integral of 1 over u du. And this is just the memorized rule. Natural log of the absolute value of u plus c. Putting x cubed minus 1 back in for u, we have the final answer. For number 18, let's let u be the entire exponent. So u will equal 3x, which means that u prime will equal 3. Let's do that substitution. So we have 2 to the u power. Instead of dx, we write du over u prime, which is 3. This 3 in the denominator can be brought out in front of the integral as a 1/3. So we have 1/3 the integral of 2 to the u du. But now comes the memorized rule. The integral of a to the u du is a to the u divided by the natural log of a. In this case, a is 2. So we have 2 to the u divided by the natural log of 2. And then we do have this 1/3 in the front, which I can write as a 1/3, or I could just put the 3 in the denominator. Something like this. Wait, I keep forgetting the constant of integration. So plus c and plus c. Putting 3x back in for u, we have the final answer. Because of a property of logarithms, there is another form of this answer that you would more likely see as an option on a multiple choice question. Here's the property. If I have a constant times a natural log, let's say natural log a, I am allowed to take this constant and put it as the exponent without changing the value of the expression. So this would be the same as natural log of a to the c power. So imagine that I did that right here. Okay, I have 3 natural log 2. Can you see this would be the same thing as the natural log of 2 to the 3rd power, because I can take the 3 and put it as an exponent. And we know that 2 to the 3rd power is 8, so this would be the same thing as the natural log of 8. So here is the version of the answer that you would more likely see as a multiple choice option. This problem looks very strange to me. Let's jump in and let the entire denominator be u, and let's see what happens. So u equals e to the x minus e to the negative x. So that means u prime will equal, the derivative of e to the x is still e to the x. The derivative of e to the negative x would be e to the negative x. But because of the chain rule, we have to multiply by the derivative of the inner function. So that would be -1. I'm going to multiply the -1 times the negative that's in the front. So that's going to become a positive. All right, this negative, multiplying by -1 turns this term into a positive term. So this is u prime. Let's make the substitution and see what happens. So we get e to the x plus e to the negative x over u. Instead of dx, we will write du over u prime, which is e to the x plus e to the negative x. Luckily, the numerator is the same as the denominator, so these will cancel each other out, and we end up with the integral of 1 over u du. And this is a memorized rule. This is the natural log of the absolute value of u plus c. Substituting e to the x minus e to the negative x back in for u, And we do have the final answer. Since the degree of the denominator wins by 1, let's go straight into our U substitution. Let's let U equal the entire denominator, 4x to the third power plus 1. That means that U prime will equal 12x squared. When we make the substitution, we get x squared over U. Instead of writing dx, we will write du over u prime, which is 12x squared. We notice that we have x squared in the numerator and the denominator, so these cancel each other out and they're gone. The 12 in the denominator can be brought out front as 1/12. So we have 1/12 the integral of 1 over u du. But it's time for a memorized rule. The integral of 1 over u du is the natural log of the absolute value of u plus c. Let's be careful not to forget the 1/12 out in the front. Putting 4x to the third power plus 1 back in for u, we have the final answer,